Hi, I am going to explain the exercise number 1. So we need to summarize the deduction of the partial differential equation for plate bending. One of the most important things in this deduction is the sign convention. So with this, we can start analyzing a bending moment. We assume a kinematic hypothesis to relate the displacement with the strain. So finally, we can express the strain as equal to minus c times a second derivative with respect to x of the deflection, as in the same way for the strain in y. With these two expressions, we apply a Hooke's law for isotropic materials, so we can express a normal stress in x in terms of strain in x and strain in y. With this, as in the same way for the normal stress in y, we can finally calculate the moment x per unit width. So this is equal to minus d. D is the bending rigidity of the plate, times a second derivative with respect to x of the deflection, plus the position radio multiplied by second derivative with respect to y of the deflection, as in the same way for the moment per unit width in y. The next step is analyzing the torsional moments. We need assume a kinematic hypothesis, so we can express a tau xy as equal to minus 2c g multiplied by the partial derivative with respect to x and with respect to y of the deflection. So with this, we can calculate the torsional moment xy as equal to d times 1 minus position ratio multiplied by the partial derivative with respect to x and with respect to y of the deflection, as the moment or the torsional moment yx is equal to minus torsional moment xy. With this, we need to calculate we need to analyze the equilibrium in the plate. So we analyze the equilibrium of the force in the z direction, the moment in x direction, and the moment in y direction. And these two last equation replacing in the first give us the partial differential equation for plate bending. Characteristics of this equation, that is partial, linear, constant coefficients, fourth order, and non-homogeneous.